I'm here on the Kennametal stand at the A&B exhibition to find out all the solutions surrounding their automotive tooling. Now, Tim, thank you for your time today. Before we get on to the solutions, can you give us a little background, a bit of background into yourself?
Thank you, Tom. My name is Tim Haudeck. I'm the responsible product manager for EV in the transportation market on the technical side. And today we can have a closer look on our tools and our possibilities in the EV segment.
So let's move over to your display, which looks really great. So what are you showing here on display?
So I think if we start in the top, we have a lot of different standard PCD tools. So you have a lot of milling cutters, different ways. We have MQL tool holders. We have special drills for MQL application in the aluminium, because aluminium parts are really common in the automotive segment. So we have PCD reamers in standard versions. We have special tool holders for tabs, milling cutters, hydroforce chucks, and then we came to all the different special tools. So different PCD special tools, combination tools. You see here you have a drilling operation combined with a milling operation, reaming operation, plunging operation, everything in one tool. And this is, especially in the automotive segment with high volume production, you find this a lot of time.
And I like how you said you've got quite a lot of standard tools that are already for the automotive sector, so that people don't have to go out and buy special tools for the more common processes.
It's depending on the operation, but we have also the standard tools. For normal milling operation, we often use milling cutters like this or here, or insert milling cutters braced with PCD blanks on it.
Now, talk us through this you have on your stand, because it looks really clever, but I'm not really sure what it is, so I'm going to rely on your background for this.
This is used in mostly every car, so it's for the thermal management of the battery. So you can imagine that the battery must have every time the same temperature. For loading, you need a higher temperature. In the driving process, you need to cool down the temperature. And this is also in your fridge at home. Yeah? It's called Skubala compressor, and we do mostly everything. So you have aluminium housing around, and then a helix, the spiral inside. Exact.
Which obviously, to get in there, that's quite a tight area.
Yeah, and you have to hold the different angles. This is really important. So you have two clampings mostly, and you have to reach the right dimensions.
So that must be quite hard work on the tools. So you've got to have a good
tools, but also on the machine and the clamping. So this the complete process is really tight. Yeah.
Now, we spoke about this side of the demo. We're going to move on. But you've machined this as well, haven't you?
Yeah, it is. It's an example of a battery housing. In the middle, you see the screen with some tooling examples, videos we have in the automotive segment. But in general, this is a battery housing.
So you're showing on this display, you're showing
it's a complete car.
The complete car. Yeah, so if we move down to the rear axle
you
of the car,
the real axle, exactly.
Now,
an electric real axle.
What has actually been machined in here?
Everything.
Everything?
Yeah, everything. So you have the stator housing with the stator, the rotor. You have all the gears and shafts. You have the cooling jacket, you can see here. So it's also used for cool down the electric engine, because you can imagine it's get quite hot inside. With inverter housings, you have the axles, you have the braking calipers, the braking discs.
And I like how you even machine the wheels.
Yeah, sure.
So it's great to see that on automotive, usually companies will have to go to different tooling manufacturers for the different tools, for the different parts. But you guys have a tool for everything.
We have tools for everything, or we can produce them. So
well,
this is
actually, that leads me perfectly onto the last two tools I want to talk about, because you can produce tools in carbide, but these are 3D printed.
Yeah, exactly. So you can see we have two different stator tools. Stator housings are the electric engines. And one of these is printed, this is the upper one. We have an MQL operation, so it means MQL, you don't have coolant, you don't have a lot of water to bring down the chips, to bring down the temperature. This is why we thought about, okay, what else can we do? 3D printing is not new, but still new. But we make a special shape on this. So we make a shape like a fan, you know, and the fan brings out the air, and the air brings out the chips. So we blow all the chips outside the stator housing. So this tool is running inside here, the chips flying away. We don't have any scratches in the finish hole, and this makes it nice.
But that's just great how you've seen the technology advancements in 3D printing and gone, how can we use that to help our customers?
Absolutely.
And like we said, you've printed this as a fan to get rid of the chips which would normally cause surface defects.
And also here is one thing you can see here, the coolant tubes, because the coolant is really coming out directly on the cutting edge or on the guiding. And also one big advantage on this tool, you can see here, we have a special inserts. The inserts is guided like in a rail. You can see here, downstairs there's a rail. And this gives us
fits in, so it cannot move.
Yeah, exactly. And also at the angles are blocked and everything is fine for the machining.
So that must mean for production runs, when
absolutely.
you're taking an insert out and putting it in, it fits perfectly at the same place your old one was.
Absolutely. So you have not a lot of preset work, I would say.
Now, I want to move on to the next one because this is absolutely unreal. I've never heard of anything like this. Tell me about this stator.
So the operation is more or less the same. We have a stator housing production in front. We have a special face cut. Okay, nothing special. So it's a milling cutter in front. But what is really new, we designed a ring on it, which is working with centrifugal forces, you know, by the rotation. So, and with these forces, we are able to change the diameter by changing the RPM. And this gives us the possibility to generate a closed loop on one side, closed loop process, so we can control the diameter. And on the other side, we have the possibility to drive out from the hole without any scratches. So we slow down the spindle if we are on the downstairs on the hole, and then we can drive out with G0.
But I like how you've used the machine to make the tool in. So one of the big problems with using a stator is when you've machined your bore and you then pull your tool back out, you're going to scratch the bore all the way out.
Correct.
But using, and I'm going to try and get this word right, using centrifugal force to pull the diameter out, when you slow that back down, you pull that out, which means you can get a perfect finished bore.
Exactly. And on the other side, you save a lot of time, because normally with normal tools you have to drive out with the same feed rate you drive in, you have to drive out. But keep in mind, these holes are really, really deep. So normally you save 20 seconds or something like that.
And 20 seconds might not sound much to a lot of people, but if you're doing a production run of 100
million parts.
Exactly. So, this has actually been nominated for the A&B award.
Exactly.
Which is just incredible.
Yeah.
So, Tim, I'd just like to say a big thank you from me and all of us at MTD for your knowledge. And I hope the show goes well for you guys.
Thank you.
Thank you.
Tom.